Guys, so we are going to continue and finish off lesson 8, day 2 of unit 2. So let's see what you're going to need today. Definitely your lesson book. If you have some graph paper, please go grab it. I want you to make sure you have a pencil and your notebook. We're going to be on page 70 and 71. You are going to be able to graph equations today and make sure if they're linear or nonlinear. So that's why I want to make sure you have graph paper because, I want you to graph with graph paper. So it'd be good if you had it, okay? So let's get started. If you need to pause to go get your items and to try to find some graph paper, go ahead and pause and get what you need. Okay, are y'all ready to get started? So let's continue with where we were. So day 1, we talked about exponents. We talked about our linear is a straight line. And remember, our line can go diagonal, up and down, and I can even have a horizontal line. But we learned in lesson 6, we cannot have a vertical line. Okay, doesn't matter if it's a line. The fact that it's a vertical, it is not a function. So in order to be linear, it has to be a function, to be a linear function. Okay, so let's look at page 70. And we want to use the equation y equals 2x plus 1 to complete the table of values. Then we're going to use the table to make a graph, and we're going to ask, does the equation y equals 2x plus 1 represent a linear function? Okay, so looking at our x values, we're plugging this into our equation. So we don't know what our y equals. So let's look at this first one together. So I'll walk you through the first 1 or 2. Then I want you to take control, and I'm going to have you finish it off for me, okay? So let's plug in our 2x plus 1. What we are going to replace, we're going to replace x every time. And then whatever our outcome is, our y, that's going to go into our y column. So I'm going to rewrite y equals, and our 2, well, we're going to be multiplying -2, and then I'm going to add 1. So let's work that through, okay? 2 times -2 is a -4, and then plus 1. So, and remember with our negatives, a positive and a negative, when I multiply, give me a negative. So two opposites do not give me a positive, they give me a negative every time. Well, when I'm adding and subtracting like I'm about to do right here, those rules do not apply. I want you to think of, I owe you $4 and I only have $1. So how much will I owe or have? Yeah, I'm going to owe still, and I'm going to owe you 3. So our first point that we're going to graph is -2 is x. So I'm going to go to -2, and -3 is y. So there's my first point. Okay. Now I want you to try the next one. We're going to plug in a -1 this time. Pause my video and go ahead and work -1. Go. Okay, let's see how you did. 2 times -1 plus 1. I should get a -2 plus 1. I owe you $2, but I only have $1. I'm still going to owe you $1. So that's going to be -1, -1. He's going to go right there. Okay. 0 is going to be really easy, isn't it? Remember, plug in that 0 into this spot right here. Pause my video, and if you can, go ahead and work the next 3. So finish me off by solving the 0, 1, and 2. Pause my video, go. Okay, did you pause? Did you finish? Okay, let's see, because I'm going to go through the rest. Let's see how we did. 2 times 0 is 0, and plus 1 is 1. So let's graph that. 0 and up 1 is right here. Okay. Let's keep going. Okay, I'm going to plug in the 1. So 2 times 1 is 2, plus 1 is 3. So 1, and then up 3, it's right there. And finally, let's do the last one. 2 times 2 plus 1 4 plus 1 is 5. How did you do? Did you do good? 2, and then up 5. Okay, so let's go ahead and step back and look what we've got. So remember, as we were talking yesterday in day 1, it's all about how I move, right? My rate of change has to be constant, So let's check our table first, and then we're going to check our graph. So let's see. What's our rate of change for my y? My rate of change for my y is going up 2. Good. What's it on my x? Yeah, that's plus 1. So my rate of change, let's try another one. Am I adding 2 again? Good. Okay, what about negative 1 to 0? Plus 1. Okay, keep going. 1 to 3? Good. And 3 to 5? Yeah, you could see that one a lot easier, huh? Okay, so we are moving plus 2 over 1 every time. Let's look at our graph. Okay, if I check out this equation, 2x plus 1, here's my y-intercept, right? Here's my my initial value, okay? And there it is right there also. And then I also have my rate of change. That's how my line is moving. So I'm going up 2 on the y and over 1. I'm going to go up 2 over 1. Let's go the opposite way. I go down and over, down and over. But look at my line. And if I continued my line, it would continue. That's an ugly line. It should be straight. But is this linear? Yes, this is linear. Good. All right, let's go to the next one. So the bottom one, now we have y equals x to the 3rd power. Ooh, okay. Day 1, you already know what it's going to look like, don't you? I think you do. Is this going to give me a line? No, it's not, isn't it? That exponent's kind of messing me up, right? Okay, so but let's go ahead and plug it in. So that way we see how this works and we can graph it, okay? So y equals negative 2 to the power of 3. And I'm going to go ahead and write this out. We're going to do this one together. Okay, negative 2 times negative 2 gives me a positive 4. And then a positive times a negative, yep, that's going to give me a negative 8. Okay, so I'm going to go ahead and put a negative 8 right here. Watch how crazy this is. It's going to be cool when we graph this one. I like exponents. We've got a negative 2 and a negative 8. Bam, he goes there. Okay, you want to do negative 1 together? Let's do negative 1 together. So y equals negative 1 to the 3rd power. Okay, I'm going to do it again. So if I spread it out like this, you can actually see, you'll be able to see it easier as to how this works, okay? Negative times a negative is a positive, and a negative times a positive is a negative. So we're going to have a negative 1 on my x and a negative 1 on my y. Okay, now I want you to pause my video, and I want you to finish the rest, okay, just like we just did. Go ahead and finish those, okay, by cubing it. So pause it. Okay, did you pause it and finish? Let's see. Okay, so y equals 0 cubed. Well, 0 times 0 times 0, I'm not even going to worry about that, so we're going to put that one there. This is going to be fun. I know, I'm a nerd. I know. I've been told, even by my son. Okay, what's 1 cubed? 1 times 1 times 1. Yeah, okay, that's just 1. So 1 and 1. Negative 1, 1. Okay, and now we've got 2 cubed. 2 times 2 is 4. 4 times 2 is 8. 2, 8. There we go. So is this linear? Nope. No, it is not linear. So it's about looking at it, and let's look at our table. Let's look at our table and see how our table looks. You ready? Okay. So how do we move from a -8 to a -1? Yeah, +7. All right, what about a -1 to a 0? +1. Yep. What about this one? +1 and +7. How weird, right? I know. It's crazy. And then these are still just +1s. But what's important to see? What's important to see? Does my slope, do I have a constant slope? No. This rate of change varies. This rate of change varies. It keeps changing. Whereas this one, what's my rate of change? It's 2. It's 2. Okay, so let's go ahead and look at the next page, okay? Let's talk about it. So I want you to pause my video, and I want to see if you can come up with the initial value, the rate of change, and is it linear or nonlinear, okay? So look, we'll do the first one together. First one, I get y equals 4x. So I have no initial value, so it's 0, because it'd be the same thing if we went +0. My rate of change is 4. That's what I'm multiplying by my x. Here's my equation. Is it linear? Well, yeah, it is linear. Because do I have any exponents? Nope, so my line will be straight. Okay, pause my video and go through number 4. Pause now. Okay, y'all ready to move on? Let's see how you did. So the initial value, do I have an initial value? Nope. My slope does vary because it's going to change every time. And here's what my equation looks like. Y equals mx squared. So is this going to be linear? Nope, this is non-linear. Okay, let's look at the next one. What's my initial value? Your initial value is 2 because it's by itself. And do I have a constant rate of change? Nope, this rate of change is going to vary. So if you got varies, good job. Is this linear? Nope, it is non-linear. Okay, let's look at this one. My initial value, good, should have been a 1. My rate of change, this one's 2. I don't have any exponents, so it's going to be constant rate of change. Because it's constant, this is definitely a linear. Good job. All right, now we did one just this. We did one just like it, didn't we? Okay, and we know there was no initial value. It went through 0. The slope definitely varied. The rate of change definitely varied. And it was definitely non-linear. Yes, definitely. Okay, so it says look at the chart in problem 4. In the equation y equals mx plus b, does m represent the initial value or the rate of change? What does the m represent? Good, it represents the rate of change. My x is going to change multiple times. See the m? Multiple times. So it is definitely my rate of change. What does my b represent? My b represents the initial value. It's the value that's by itself. So here's your rate of change. Your initial value is what's by itself, right? So my y, well, my initial value is what I'm starting with. It's what I'm going to begin with before I start having multiple x's, right? Okay. So number 6 says, according to your observations so far, what equation form or forms define a linear function? Pause my video and think about this because I want you to ask yourself why. So why do you think so? So out of the forms, what is an equation okay? And look, you've got several to choose from right here, okay? You've got several to choose from. What are the forms that you would use, okay, to define a linear function? Pause my video and answer number 6. Okay, let's see how you did. Did you write y equals mx or y equals mx plus b? Did y'all use those two? Good, because these are the ones who give us a linear function. It's the ones that are going to have a constant change. They're going to change at a constant rate. The exponents, we don't have a constant rate, okay? So our last thing, it says try another way. Work with your group, which y'all are at home. So talk out loud, talk with your dog, talk with your mom or dad or uncle. But try to predict which one's going to be linear, okay? And on your graph paper, I want you to graph them. So you might have to pause my video for a few minutes just to try to graph them. I know you can do it, okay? Remember that equivalent from 0.5, an equivalent fraction is 1/2, okay? And you're just really dividing by 2 and getting half. But if you want to plug them in your calculator to check yourself, go for it, okay? So please pause my video. Which equation, decide if it's linear, and I want you to graph them, okay? Pause my video. Hopefully you worked really hard on this one, okay? So did you say that 7 was linear and that 8 was non-linear? Because line, it makes a straight line. Okay, let's check your graph. Let's see if your graphs match my graph. Oh, well, my blue one has seen better days, but check your graphs and see how your graphs match with mine. Okay, so ultimately, guys, when we're looking at this, we want to make sure that if we're at a y equals mx or y equals mx plus b, it's going to be a straight line every single time, okay? So good job today, guys. And hey, you finished another lesson. That's lesson 8. So good job. Y'all have a great day, and I will see you at lesson 9. Okay? Bye.